Hi friend, how are you? Again, I'm coming in my new topic. Everyone saw the headline bar bending schedule. So this means today my topic is bar bending schedule. This is the very big topic. Maybe here too much discussion about the this bar bending schedule, and here a lot of the formula also there. So this topic maybe I will finish 2 or 3 videos. So this first video, I will discuss about the bar bending schedule. What is the bar bending schedule? And this short form is BBS. Why we are using the BBS? What is the benefit of the BBS? And then after, I will discuss about the external length of the steel bar. How to get the external length of the steel bar? I have some formula. We are using this formula and get the external length of the steel bar. Then density also I will discuss about what is the density and steel density, and 2 3 topic also. Hook length, cutting length. I will discuss about the hook length and cutting length. Also the picture also. I have a picture formula, and then crank band. How to get the crank band length. So friend, we are start this video. First, first of all, I will discuss about the bar band BBS definition. Why we are using the generally we are using the BBS because I will save my time and reduce the project cost, because I have everything. What is the column size and beam size, slab size. So I will order that time. I will same size. I will order. So I reduce the wastage. That is the main benefit of the BBS. And second thing, I will order this factory. I will tell the size also. So this size, same size is cutting in the factory. Then after he send me the bar, so I have also saved the time for cutting. This two big benefit of the this bar bending schedule. And third is some time we are every site engineer prepare the estimation, cost estimation before starting the construction. He give the client detail and amount also. So that time also use the bar bending schedule, because he knows the how much bar use this construction site. Then he this time he knows also rate also this one, if properly calculate, and then give the quotation also. The those 2 3 types use this PBS. So friend, here I have little topic of the bar bending schedule BBS. Before before dealing with the BBS, it is very important to learn to basic of bar bending schedule. The below men so when the below mentioned table is a kickstart guide for learning bar bending schedule for scratch. So friend, this is the table. One by one I will discuss you. This is important of the learning bar bending schedule. The first topic is here the standard standard length of the steel bar. We are sold out the shop, any shop. The I know the what is the standard length of the steel bar. This is the 12 meter and 40 feet. 12 meter and 40 feet. This is the standard length of the steel bar. My second topic is how to get the weight of the bar. I don't. First of all, how to get the bare weight of the bar is 1 meter. This total length of bar is 12 meter. I know. First of all, I have so the formula. This is the formula is the d square upon 162. This is the formula. What is the D is the diameter of the bar. So this formula I will put this one all value and get the answer. For example here, so the example, if length of the bar is 12 meter, I know this is the standard length of the bar, and diameter is 10 meter, 10 millimeter. Here, so the diameter 10 millimeter. So for easy, I will put the all value in this the formula. So here 1 meter. Now I will getting the weight of that 1 meter. So this 1 meter into d square. 1 into d square. D means diameter bar here 10 square upon 162. I will solve this one, and answer is 0.61 kg. So this is the 1 meter of steel bar weight. Now we are get the 12 meter. This is the standard length of the steel bar. So we get the 12 meter weight. So same like this here I will put the 1 meter. So I will put here the 1. I will now I need the 12 meter. So here I will put the 12. Same 12 into 10 square in upon 162. Then get the answer. Answer is the 7.40 kg. So one steel bar weight is 1 steel bar 10 dia weight is 7.40 kg. And my third point is the density of the steel. Density of the steel, the 7,850 kg per meter cube. This is the 7,850 kg meter cube. This is the value of density of steel. So friend, below I am discuss the different concept of bar bending schedule, which are very useful while working with BBS. All this concept are used in BBS design calculation of any structure member. So be familiar. So be familiar with the below concept. Means I will discuss about this point. This point always I will do the bar bending schedule. So always I will use this point. So that means I will very familiar this point. I will show the point. First point is the hook length of cutting hook length or cutting length of stirrup. This is the first point, hook length of cutting the stirrup. So friends, this is the hook length here. So the hook length is commonly provided for stirrup. Hook length, this is the stirrup. Everyone saw the picture. This is the stirrup. The stirrup, this one is the hook. So every stirrup, commonly I will provide the hook length. So here this is the hook length, and beam I will provide the stirrup, and then column. This name all different. Beam I will tell that this one is stirrup, and then column I will use this one. But I will tell the tie. So generally hook length is 19D, or everyone knows that D is the diameter of the ball. Below that, this is the hook length. This is the hook. Below the image make you clear why the hook length is the 19D. See this one, total length of the hook 1 into 1 to 2 into 2 plus 2 into 3 plus 3 to 4. This is equal to 4D plus D plus 4D. The total is the 90. This means the hook length is the 90. There is the formula curve. This is the curve now. This is the curve. This curve portion plus 4D. So here the curve portion is the 4D plus D is the curve portion plus 4D. To calculate, I will solve this one to get the answer is 90. That's why hook length is the 90 and D is the diameter of bar. I will use all BBS, I will use this one because what is the BBS? Construction side beam column. Every side I will use the beamer column. I will use the beamer column. So definitely I will provide the stirrup and tie. There I will provide the stirrup and tie, and then I will provide the hook. So every time I will calculate the hook length. So friend, I hope you clear the hook length. This is the hook length is 90. Now go the next point here show the hook length. This is the stirrup, or this one used in column, so this is the tie, and this one is the hook. So second point mine is, friend, this is the formula. Total cutting length of stirrup or tie. Stirrup or tie. Total cutting length. How to get the total cutting length? I put the value of this formula and you get the value of the cutting length. Total length of the bar plus 2 into hook length. 2 hook. Total cutting length equal to L. L is the length. L is the length. Total length L in plus 2 into 90. Therefore, total cutting length equal to L plus 18D. Because why I will put here 2? Because here provide the 2 hook length. That's why I'll put the here 2. Agar I will provide that there only one hook, so I will not put here the 2, only 90. So here provide the 2 hook, and this means I will put the 2, and the answer is L plus 18D. D is the diameter of the bar. I will put the value here and get the answer of the cutting stirrup. And where get the L value? L value so in the sub drawing. I will read this sub drawing there. So the everything. My second point is band length. How to get the band length? This band length, friend, this is the band. Generally, I will provide this band in slave side. I will put the slab there with the provide the crank bar. This is, I will crank this. So friend, I show the diagram of the band length. So friend, here for the above figure, as the bar is bent at angle theta, the additional length LA is introduced, where LA equal to L1 minus L2. Then tan theta equal to D upon L2 equal to sin theta equal to D upon L1. Hence L1 equal to D upon sin theta and D2 upon L2 equal to D upon tan theta. Therefore, A equal to D upon sin minus D upon tan. So here the value of theta. Sometime band that sometimes we are bending 30 degree, and this band sometime we are bend the 45, 60, 90 and 135. So this is the value of LA. Or shall we use this value? So, my friend, you learn this one. You learn this table though, or you 5 time you use this formula. Automatically this value you put in your mind. No, too much learning upon. Only use this one. You continue use. Calculate 1 time, 2 time, 3 times, it automatically fit in your mind. So friend, here the example of the calculation considering band up bar in slab. Mainly I will band I will provide the slab. This called the band called the crank bar. To keep the crank bar in position, an extra bar of length LD. They provide the extra length to this is the LD. This is the formula. You also learn this one LD. Extra bar of the length LD is provided below the crank bar as so. I will show the figure also. So the see friend, this is the figure of the crank bar. Or here the extra bar. Here I provide the extra bar. This is the 4L 4 by L. This is the extra bar, and this is the deep of the bar here also. The figure therefore the total length of the bar. How to get the total length of the bar? L plus 0.42D. Why use the value of 0.42D? Because friend, this crank bend in 45 angle. You know, I tell you learn this table here. He here the 45. He bend the 45 angle. This bar to use 0.42D. Oh, that time he used the 60. He bent the 60 degree. Then we are using the 0.58D. So now here he bend the 45 degree, both side. So there I will use the 0.42D, 0.42D. So same this one L plus 0.42D plus 0.42D plus L by 4. This length L by 4 or L by 4 plus L by 4 plus L by 4. Total is the 1.5 L plus 0.84D. This is the value here. Here put the value of D and L and you get the answer. Remember D, I will tell you D is the deep of the slab. This is the deep of the slab, and minus because I will provide the cover. So don't forget you minus also clear cover upside and clear cover downside. Then you get the value of the this deep of the slab bar, because we are provide the clear cover both side, up and down side, bottom side clear cover, and upside also provide the clear cover. This is the formula of the total length of bending, therefore the total length of bar. This third one is the band length calculation. Band length calculation when bar are bent at corner. The important standard use will calculating the band length of corner. We are bend the 45 degree, then I will use the 1D. We are bend the 90 degree, then we are using the 2D or 135, then we are using the 3D. For example, here is the example. Here, this is stirrup. Here we are bend is 90 degree. Here also we are bend the 90 degree. But here I am bending this one 135 degree. So 3 times 1, 2, and 3. 3 times use the 90. So I will use the 2D, and 2 times I will bend this one is 135 degree. There I will use the 3D. For our figure, there are 3 bend 1, 2, 3, which are bend at the angle of 90 degree. This 3 bend is the 90 degree, and 2 bend are bend at an angle of 135 degree. total band length equal to 3 into 90. Why? Because 1, 2, 3. So 3 into 90 band length plus 2 into 35, because 2 times of band is 135 degrees, then 2 into 135 band, and length equal to 3. This is the number of band 1, 2, 3 into 2d, because this is the band is 90 degree, the 2d plus 2 into 3d. 3d is the by one, here I bend the 135 angle, that's why I put the 3d equal to 12d equal to 12 into 8, because here so the stirrup size is 8 mm. So now I am putting the value is d diameter of the bar, so 12 into 8 equal to 68 mm. I get the band length. This is the formula of the band length. Now friend, my last topic is this topic I will discuss about the different shape of stirrup bar, or how to calculate this one. So here the different shape of the bar. So this one here provide the 2 hook length, 1 and this 2. So here provide a 2 hook length equal to 9 plus number of bar 2, so 9 into 2 into 18d. This one here provide the 2 hook length plus 1 crank bar, also provide that this crank angle is 45 degree. So 2 hook length, so 9 into 2 equal to d, 18d. Then 45, this crank band is 45, so we are using the 0.42 t. Here same 2 bar, and both sides provide the crank bar also. This angle is 45. So 2 hook, to 9 into 2 it is 18, and then 2 crank bar, so 0.42 into 2. So these 3 types of different shape of a hook we are providing the. So how to calculate the hook length? Use this formula and put the value and get the answer of the length. So friend, now I will finish this my video, because this video is very long. Next time I will come here, then start the again this. Today I will finish the stirrup. Then next time I will start the PVC in the column, how to calculate the column, and beam also this video. So okay friend, see you in my next video.